we're going to learn the product rule. So the idea here is if you've got y as a function of two things which have been times together. Now u and v here aren't constants, they are variables, they are functions of x. So both u and v are something to do with x. They could be like x cubed or sine x or that sort of thing. If we know what each of these things differentiates to individually, then this here is the product rule. So to work out dy dx, the goal of all of these things this week, we would keep u the same and differentiate v to get that one over there, times them together. And then we do it the other way around. So we keep v the same and we differentiate u and we times them together. Notice here, this is all symmetrical. You can pick u and v to be whichever way around you like. We're just adding these two things together. Now you're not given this rule in the exam, you have to remember it. It's harder to remember written down like this. I'm always going to lay it out in the same way, and I'm going to show you an example of how we're going to use it. So, here is y as a function of two functions of x times together, x cubed times e to the x. Now it doesn't matter which way around we pick it. We're going to pick u to be one of our things, so u could be x cubed, and that means v would be the other bit, e to the x. Well, we need to differentiate both of those things, so du dx would be differentiating this one up here, which would be 3x squared, and dv dx, well, e to the x just differentiates to itself, like in the third video. Okay, putting it all together, dy dx equaled u, which was x cubed, times by e to the x, plus the other way around, v, which was e to the x, times by du dx, which was 3x squared. So it's that times that, plus that times that, or the other way around. It doesn't matter. If we wanted, we could do some factorization of that, but we're done. I'm going to do one more example, and then I'll give you one to have a go at. So again, I'm going to lay it out in the same way. Let's have a go at y equals x log x. Once again, I'm going to pick both the bits. So u equals, well, it could be either of them, but I'm going to pick x. We'll have v equals log x. Differentiating both the bits, du dx equals 1. And dv dx, again, this is one of our standard results that you just have to remember for the exam, but it was in video 3. It'd be 1 over x. Okay, putting them all together, using the product rule, dy dx equals that times that. So x times 1 over x, which is just 1, plus that times that. Well, log x times 1 is just log x. Done. Right, here's some for you to have a go at. Have a go at this one. Y equals x squared sine of x. You might want to pause the video now, and I'll go for the answer. Okay, here's the answer. So I haven't bothered writing down u and v, but I kept u the same and differentiated that one to get cos x, and then I kept that one the same and I differentiated this one. If you wrote out the u's and the v's, you should get the same thing. Right, cool.